Hello students, welcome to your classical mechanics class. As we are talking about the system of particles, n number of particles in a system. So today we will see the relation between the torque and angular momentum of the system of particle about the center of mass. As in our previous lectures we considered the system of n particles 1 to 3 and n particles whose masses are m1, m2, m3 and their position vectors are r1, r2, r3 and so on rn with respect to the position of the coordinate system. Particle 1, 2, 3, 4, ith, gth and so we have n number of particles in this system and their masses are m1, m2 and so on and their position vectors are r1, r2 and so on. So we are interested, as in our previous lectures, ith particle. So suppose this is the ith particle and position of vector of this ith particle with respect to position is r I. Now suppose this point is the center of mass and the position vector of center of mass with respect to O, as we consider, is vector capital R. Now, if Ri prime is the position vector of the ith particle with respect to center of mass, then from triangle of vector addition we have vector Ri equal to Ri prime plus vector R. This is the position vector of ith particle with respect to center of mass. So as in the previous lecture we had discussed about the torque. Torque is R cross F. Now we are interested in ith particle, so this is tau I equal to Ri cross Fi. So what is this Ri is Ri prime plus R, so we will substitute this value here, so it will be Ri prime plus capital R cross I. So we can rewrite this equation as Ri prime cross Fi plus R cross Fi. So what is this Fi? Fi is the force acting on the ith particle. So this force is the sum of all the external and internal forces, vector sum of all the external and internal forces acting on ith particle. So we can write this force Fi as Fi external force acting on the ith particle plus force on ith particle due to jth particle. So that is Fij, this is the internal force. So since we have n number of particles in this system, so we have to sum it over j equal to 1 to n. So this is the total internal force acting on the ith particle due to all the particles in the system. So this is external force, this is finally Fi. So we will substitute this value here. So it is Ri prime cross Fi external plus summation j equal to 1 to n Fij plus R cross Fi plus summation j equal to 1 to n Fij. So this is the torque acting on ith particle. Now the total torque acting on the system is tau equal to summation I equal to 1 to n tau I. This is the sum of the torque acting on all the particles. So that's why I write it summation I equal to 1 to n. So tau I is, from this equation we can substitute I prime summation I equal to 1 to n Fi plus summation j equal to 1 to n Fij plus summation I equal to 1 to n R cross Fi plus summation g equal to 1 to n Fij. Okay, so now we will rearrange this equation. Summation I equal to 1 to n Ri cross Fi plus summation I equal to 1 to n summation j equal to 1 to n Fij Ri cross Fij plus summation I equal to 1 to n R cross Fi external plus summation I equal to 1 to n summation j equal to 1 to n R cross Fij. So this is the rearranged form of this equation. We have considered the sum over all the particles. Since all the internal forces are equal and opposite, so that's why summation I equal to 1 to n summation j equal to 1 to n Fij is 0. You can go through the previous lectures for this. And the resultant torque due to internal force acting on the system of particle is 0. That means we are talking about this Ri prime cross Fij. This is also 0. So this is summation I equal to 1 to n summation j equal to 1 to n Ri cross Fij. What is this? This is torque Ij. So this is also 0. You can go through the previous lecture for this also. So finally, with the help of these two equations, we have total torque is torque equal to summation I equal to 1 to n Ri cross Fie. So it is prime quantity. This term is 0 and this term is also 0. So finally plus summation I equal to 1 to n R cross Fi external. So what is this Fi external? We can rearrange this as summation I equal to 1 to n Ri prime cross Fi external plus R cross summation I equal to 1 to n Fi external. This is the total external force acting on the system. So we can write this as Fe. This is the total external force acting on the system because it is the sum of all the external forces acting on the system. And this Ri prime cross Fie, this is torque. This torque is about the center of mass because this Ri cross Fi is the external force acting on the ith particle. So this is the total external torque acting on the system relative to the center of mass. This part is center of mass. We can write it as this is torque Cm. First term in this equation is torque about center of mass plus this is R cross F. What is this R cross F? R is the position vector of center of mass from the origin cross F. F is the force acting on the system. So that is the force acting at the center of mass point. So finally this is the torque of the center of mass about the origin O. So we can write it as. Now in our previous lecture on the angular momentum, we had found out that angular momentum vector L is vector L prime plus LCm. If you remember this, otherwise you can go to the previous lecture. So but in this L prime, it is the total angular momentum of the system of particle is the vector sum of angular momentum of center of mass and angular momentum of all the particles relative to center of mass. So this is found in our previous lecture. So what was this L prime and LCM? This is R cross M into V. It's better to write in this form. M is the total mass of the system and V is the velocity of center of mass plus LCM. It is, but is vector R is the position vector of center of mass with respect to origin. Now, if we differentiate on both sides, then vector dl by dt equal to R d by dt cross M v plus d by dt R vector L about center. So we can rearrange this as M R cross dv upon dt plus dl by dt. So what is this dv upon dt? This is the acceleration rate of change of velocity. So we write it as d vector a, small a, and this is d vector t. How I write this finally? Because if we go in the vector product, this product formula, this is here, it is dr by dt cross mv plus r as it is cross m dv upon dt. So since this term is also v cross v, so v cross v is always 0. A cross A is sin theta, sin 0 is 0, so that's why I skip this term, finally write this term only, R cross M dv upon dt, so I write this in this form. So M R cross A plus dLCM upon t. Now, this mass into acceleration is the force, so we can write this R cross F. But in this force, external force acting on the system dl upon dt is dl by dt. Now this dl by dt is torque, we know, and we know this torque is tau cm plus r cross f. If we compare these two equations, we have from this equation and from this equation we have tau cm plus R cross Fe equal to R cross Fe plus dLCM upon dt. So these two terms are same on both sides. Finally, we have tau Cm equal to dLCM upon dt. So this is the outcome from this derivation. So this equation states that the torque of external force about the center of mass, Cm represents, is equal to time rate of change of angular momentum, dl by dt, and Cm represents about center of mass is equal. So this equation is very identical to our previous discussion on tau equal to dl by dt. So these two relations are very similar. The difference is only the term Cm. Cm represents the center of mass. Okay, so these two terms are identical, but there is one fundamental difference between these two terms or equations. This term tau equal to dl upon dt, this term holds good only if both the angular momentum and torque are evaluated with respect to fixed origin of an inertial plane. On the other hand, this term tau Cm equal to dLCM upon dt, these terms holds good if both angular momentum and torque are calculated about the center of mass. About the center of mass. So the center of mass may be or may not be at rest in an inertial frame. Thus, this expression tau Cm equal to dLcm upon dt holds good irrespective of the motion of center of mass. So this is a remarkable property of the center of mass. In the next lecture, we will discuss about the external potential energy of the system of particles. Thank you for watching.